Hello everyone. I'm Tomáš Šárocký from DataFromSky, and it's my pleasure to be part of this session. I'm here connecting from Central Europe, from Czech Republic, and I'm more than happy to tell you a bit more how to utilize artificial intelligence in the real world of traffic. Let me dive in. First of all, let me just very briefly explain who we are and what we do. We are a Data from Sky team, established in 2013 in Czech Republic, Central Europe. And since then, since those 10 years, actually, we celebrated the anniversary last week. Since those 10 years, we gained almost 500 customers in more than 50 countries worldwide. Since those 10 years, we gained strong partnerships within academies and universities around the world, which helps us a lot with our research and development and new feature release. And at the end of the day, our technology would be nothing if we don't cooperate with other technologies and other technology partners. Here you can see some examples such as Access Communication, Unix Traffic, Milestone, NVIDIA. Maybe you know some of those names, maybe not. At the end of the day, our system, the system we develop, needs to integrate and is integrating with integrated with other technologies, other partners. So what do we do? In two words, a Data from Sky, we do computer vision. So we take the image and we analyze what we see in the image. We do it for the traffic environment, for the traffic use case, and that's our core business. Back when we started, we introduced a solution called Traffic Survey. Traffic Survey service is very simple and straightforward. You just record a traffic situation, either it is a highway or an intersection, and upload the video footage to our server. We process it using our artificial intelligence and give you the data back. This is mostly suitable for traffic planners or traffic engineers when they want to do some surveys. So instead of paying some student who would sit at the intersection and do manual counts, this is a fully automated system where you can get much more data than just simple counts and classification. But you'll see later as well. Second solution which we came up with was parking detection system. It is, again, a system using computer vision, so recognizing vehicles from image, but this time in real time and for a parking use case. So using this system, we are able to recognize free and occupied spots on an parking lot. And our latest release, our latest solution, actually a flagship solution, is called Flow. Flow is somehow a combination of the two. So it, in short description, it is real-time traffic analysis from cameras, of course. Now, how does Flow work? Or what Flow can do? We internally call it a visual traffic solver because it can solve dozens of various issues. So it can, for example, provide you data about traffic monitoring, so standard counts and classification of various classes on different places on the road. It can detect various events, and those might be either some violations, like, I don't know, U-turn or wrong way driving, but it also might be some of operational nature, like stopped vehicle or blocking vehicle or an accident and so on. These events we can then further utilize within Flow for some traffic control. And it might be, again, either on the intersection or on the highway with some variable message signs, or within the tunnel to inform the tunnel operator of certain situation happening within the tunnel. Flow can be also used as a parking sensor. As we talked about, flow also can be a detector of free and occupied spaces on parking lot, but also can be used for some safety monitoring. So as I already said, it can detect either actual incidents, but also, and more importantly, near misses. So situations which were dangerous, but fortunately didn't end up with an accident. And these situations are, at the end of the day, even more important to monitor, because you have to know those dangerous situations on the road. Those will never show up on any report, and with our system we can measure and detect those. Last but not least, flow can be also used within monitoring of vulnerable road users such as pedestrians, cyclists, pram, wheelchair, e-scooter, and so on. And those might be either on an open space, so on a street or on a square, or even at the end of the day, or even also inside of a building or a shopping mall, if you wish. Here you can see some examples what flow can do and what kind of data it can provide, from volumes and classification to some speed detection, origin destination metrics, distances between vehicles, traffic flow accuracy, like the traffic jam detection, wrong way driving, forbidden turn detections, and so on and so forth. This is really just an example to demonstrate the functionality. At the end of the day, when we were developing flow, we were focused on three main aspects. First, and the most important one, trajectory-driven design. Second is precision, and third is that we can utilize any cameras. Talking about trajectory-driven design, it is a very simple approach. First, we take the image and we detect what we can see in the image. So we classify all the detected objects into 18 categories, like car, tractor, bus, van, cyclist, and so on and so forth. And we know where exactly they are. Second step is that we track those detections and we create continuous trajectories. So we know that this black car is turning right, this one over here turned left, and this yellow one here went straight. And that is the outcome of the software. Now, we as users have to come into play and take the data what we want. So, for example, by drawing a gate here to get the counts and classifications here, or by drawing a zone in this area to monitor parking occupancy. Or, for example, we want to know what is an average waiting time here at the stop bar. So we will draw a zone here and we'll be monitoring the average time vehicles are waiting there, and so on and so forth. Like in this way, we can create dozens of different sensors we need. Um, the second use case, or the second point, the precision, you can see demonstrated here on this video. You see the speed, you see the bounding box, you see the distances between vehicles, and so on. This precision is mostly used for safety monitoring, as you can see, for example, on this example, where you see the bounding boxes of near misses. So some sort of dangerous situations, which fortunately didn't end up with a collision, but if nothing would change in trajectories of those two objects, there would be a collision within half a second, 1 second, something like that. These kind of situations we are able to report, and their position and so on. The third pillar on which we build flow is that we can utilize any camera stream for the system. So it might be panoramic camera, it can be CCTV camera, even PTZ cameras. It might be. Probably the only type of camera we don't like is fish eye, so 360. but even that one can be split into some sort of a quad view where you see 4 different streams, and that is already workable. Here you can see an example of a standard CCTV camera, and I love this scene very much because there might be dozens of various detections here on this screen. So, for example, we can do simple counts and classification here at this gate. We see here is a sign forbidding to make a U-turn, so we can very easily detect drivers which are violating this rule and making U-turn here. On the right side, there is a cyclist path, so we can very easily monitor and count number of cyclists using this path. We see here the traffic light, so we can detect its state based on the color. And if someone is crossing this gate and there is a red color, of course, it's running on the red light, and we can report it as well, of course. We can create a simple small zone here, which would be like a virtual inductive loop, and that would send an information to a traffic light controller about green request on this arm of the intersection, and so on and so forth. We can think of some other use cases what we could utilize this view, but don't want to spend too much time here. And this, what you see, all of these use cases, we can do within one system, within one user interface, in one license. And that is one of the third main USPs of Flow, that you can integrate hundreds of different sensors into a single one, into a single system, to a single user interface. The second one is that it is very easy to configure and start with. As we utilize artificial intelligence systems, you just connect RTSP stream, so the image from the camera, and the detection starts right away. There is no need for any extra configuration for the detection. It simply works. And the third point, the third main USP is that the user interface is very easy and simple to work with. And what I mean by that is shown here on this short video example I prepared for you, where you can see the live user interface, how it looks. You see the detections, you see the trajectories divided by color based on categories. And here we can draw some gates and a movement between them to define the movement we want to filter. Like by drag and dropping it here to the workspace, we are already filtering the movement. We can add some category filter, and now we are filtering only these categories which crossed these two gates in this particular sequence. In very similar way, we can create a wrong way driving detector by two gates and a movement in an opposite direction. And again, drag and dropping it to the workspace, and we have a wrong way driving detector within 5 seconds or so. The same principle applies also for the U-turn detector, where again, two gates, movement in between them, giving us the shape of the U-turn, and we are detecting if someone is making a U-turn on an intersection. Another use case I just want to mention is, for example, creating the zone like this one, where we can either count number of vehicles waiting at the stop bar right now. We can also measure their time. We can get a notification if the average waiting time in the zone is more than, I don't know, 30 seconds or something like that. So we can play around as much as we need to get the type of data we really want to get out of the system. And let me just fast forward a little bit here, where we have a visualization of the data on the dashboard. So using various widget types, which we simply attach to the created filters, we can visualize the data on a dashboard, which is customizable, and we can very easily work with it. and create it in the way we want and we need. So this is an example how the user interface looks like on this kind of scene. It has many different features as well, but don't want to waste time on that. What I want to show you is one more thing. And so far I was talking about flexibility within the software. But Flow is also flexible towards the hardware. Because at the end of the day, Flow can run either on the edge, so some edge computers, but also it can run on in-house or centralized servers. If we are talking about edge deployments, it can run directly on the camera itself. So those are some special AI-enabled cameras. We can provide one of our own, or there are some vendors and models which we support as well. And this is a standalone device which doesn't need any server, any cloud, any internet connection. It works on its own. The second edge device or platform is called either Traffic Embedded, as you see here, or Traffic Crossroads. This device is installed in a cabinet, outdoor cabinet, somewhere on site, where multiple cameras can be connected to it, and it analyzes those images on the edge. Again, it doesn't need any server, cloud, or internet connection whatsoever. Everything is happening here. This is usually useful when there are already installed some cameras on site and we want to utilize them. So we will deploy this traffic embedded device. The third option, how to deploy Flow, is the centralized server, where I believe all of you can imagine how server looks like. And we can connect dozens of cameras, hundreds, and maybe even thousands of cameras to the server room, analyze them on the server, and get the data we need. Each of the three deployments has its own advantages and disadvantages. I cannot say which one is the best. I can only say that each one is used for different scenarios, different customers, different purposes. So it needs to be discussed, but all of the three options are possible. So to sum it all, Flow can integrate hundreds of different sensors into a single user interface where you define what kind of data you want to get out of the system. If you want just statistics, or you want some events, if you want to send those events to a third-party system and do some actions, that's very open and very flexible. It is simple to start with. You just connect the image stream to the system, and the detection starts right away without any complex configuration needed. And last but not least, you saw the user interface is very easy to work with, and I heard feedback it's like Apple style. So that's one of the I see one of the huge advantages of the whole Flow platform. That's all what I wanted to show you. I hope you liked it, and if you have any questions, just ask. I'll be here for the questions and answer sessions. Thank you very much for your attention, and looking forward to stay in touch with you.
各位嘉宾，大家好，我是景翊科技的业务经理，我叫 Alice。那今天很高兴，就是刚的影片，大概替大家做一个做一个简短简要的一个介绍。那 DataFromSky 是我们代理捷克这家公司在专注在交通分析上面的一个软体。 它除了可以 real time 的在线上及时的去做交通的一些分析，它也可以做一个离线的一个事后的一个分析跟改善。那在影片中，其实大家可以看到，它可以很方便又很简单的、及时的去拖拉、去产出你所需要的交通分析，或者是追踪你想要追踪的一些交通改善的问题。所以它在操作上、在使用上，它很便利，而且它可以把现有我们智慧化城市里面入口的一般的 AI camera， 一般的 IP camera， 它就可以直接把它串流进来做交通的分析跟使用。所以在交通上面的应用，不管是在你的预算上，在你的品质上，甚至在你交通问题的追踪、检核、分析，以及最后事后的改善的成效，都可以在最短的时间之内做一个呈现。那简要我给大家做一个说明。那后面我们原厂在线上做一个 Q&A， 谢谢。
谢谢，那我们也谢谢线上连线的 Tomáš 和 Alice 为我们讲解。那想请问一下现场来宾有任何的问题，就可以针对我们刚刚讲的内容，可以进行一个发问。好，那我们再次谢谢那个线上连线的 Tomáš还有 Alice 这边为我们的讲解，让我们再掌声鼓励，谢谢他们。